Okay, let's go ahead and go over this.
Alrighty.
Physical and chemical, what's like the ultimate difference between these two? Something like that. Did the formula change? That was a chemical change. Did the formula not change? That wasn't a chemical change. If you put down change color, precipitate, or presence of a gas, then that's how you can observe it, but that's not what's happened. The reason that you saw the precipitate, the change in color, or the generation of the gas is because I had a chemical formula change. So it's all about changing that formula. So if I'm physical, all I'm doing is changing the state, like liquid water to gaseous water, solid water, something like that. Whereas if it was a chemical change, it would be water. Now it's turning into hydrogen gas and oxygen gas.
So like it's just a new substance? Like
New substance, yeah. New substance means the same thing as changing the chemical formula. Unit, what do we need for this?
Standardized term.
All right, so one, the unit measures stuff, that one's obvious, and the most important part about those units is the fact that everybody agrees that that's what the unit is, so it's standardized. Why was this developed, the metric system developed? Okay, so I can make everyone except us standard. So I want to standardize everything. And then what's the other part?
Super simple.
Simple. So if I'm going to start from scratch and make a new unit system, I'm not going to randomly pick numbers and say this is equal to that. I'm going to make it super easy. And the way they made it super easy is because they based the whole thing on what? No. Powers of 10. Yeah, I based it on 10. So when I'm talking about things, it's 10 times bigger, 10 times smaller. 1,000 times bigger, 1,000 times smaller. There is never going to be a time when you have to memorize 5,280 or 2.54, right? Or 1740, 1760, 1760, is that right? How many yards are in a mile? See? Yeah, like don't even want to know that. Like how far is it around a track for like track and field events?
400 meters, 440 yards.
400 meters, 440 yards. 400 meters makes a lot more sense than the 440 yards does.
It is a measurement.
Okay, so decimal format on this one, I've got times 10 to the 5, so I'm going to take this thing and multiply it by 10 5 times. Every time I multiply it by 10, what happens? Move the decimal place to make the number bigger. So 2, 3, 5, 8. Do I put a decimal place there after the zeros? What would the implication be if I put a decimal place after those two zeros? I measured it to the ones. So did that happen? I only have 4 significant figures. So what are these two zeros acting as? What they're saying is this number isn't 2,358. It is 235,800. So I can't not have the zeros. But the important part is these two zeros could be what? Could be 0, 0, or they could be 99, or any number in between. I have no idea what they are. I only am sure about these 4 numbers here. So unsure about those two. So if I put a decimal place down there, that means the person actually put this stuff on a scale or measured it with some device that measured it down to the single unit, which this absolutely does not do in this particular case. So no decimal place there. Next one, scientific notation. What's this one look like?
6.5895
times 10 to the fourth. Excellent. Okay. Next one. What am I doing with this one? How's this one different? I'm dividing by 10 3 times, right? And every time I do that, I make my number 10 times smaller. So I'm going to have 0.005894. Okay, so we haven't discussed this, but since nearly half of you are trying to get into the nursing program, I want that right there. I want that 0 in front of the decimal place. I want that 0 in front of the decimal place because in the field of nursing, you put a 0 in front of the decimal place because it makes it more difficult to make a mistake. So if there's a blank in front of that, maybe they don't see the, maybe you have a number like 0.58, grams per milliliter, or let's say, let's say it's milliliters per kilogram. Maybe this is your dose, milliliters per kilogram. Great. Well, what if this decimal place that was put there is not very bright, not dark, or kind of disappears, gets smudged off? Now what does it look like? Now it looks like 100 times more of a dose than the person's supposed to get. But if there's a 0 written right here, and you don't see the decimal place right here, what should you be thinking? There's probably a decimal place there, and I'm going to go find the person who wrote this and figure out what exactly is going on, as opposed to just simply seeing what you think is just a 58 and assuming there's nothing wrong there and just running with that. So 0 decimal place the rest of the numbers. Anybody who's like a chemistry major and you go on later on, it's really not important. It just really, nobody in chemistry is actually going to cite you for it. They'll probably actually make fun of you for putting an extra digit down that doesn't need to be there. But in because most of the time they're not actually killing somebody, but in nursing, literally we're talking about easily killing somebody by missing a decimal place. So for this class, anytime you write down a point and then some numbers after it, make sure there's a 0 in that one spot, like I do for this next one. So the scientific notation for this one, it's going to be 9.23 and then times 10 to the, what am I putting up there? -4. Yep, -4. Great. All right, we're going to convert 285 inches into meters. So I'll put 285 inches up here, and I want to go to meters. So where does my inch need to go? All right, great. So I have inches down here. They're going to cancel out, but I need to make this guy right here equal to 1. So what do I do? 2.54 centimeters, because those two things are equal to each other, exactly equal to each other. Great. So I've moved from inches into centimeters. I need to go one more step. So to cancel that centimeter unit I put in there, I need to put this down here. So now what do? There are a couple of things. I can go directly into meters. So the two things I could do would be to put 1 centimeter and 0.001 meters up there, or I could put 1 meter and put, 100 centimeters. I always like to see it like that. What I do is I take the larger of the two units and put a 1 next to it, because it's easier for me to think about, I have 1 meter. How many of these little centimeters will fill 1 meter length? And the answer is 100. So the other way to think about it is, I've got 1 centimeter. What portion of a meter is that? Well, it's 0.01. Well, I always think it's easier to think about lots of little things equaling a big thing as opposed to thinking how much of this little thing equals that big thing. Do it however you like. I just think the easiest way to do it is whichever the two units is larger, put a 1 next to it, and then think about how many of the smaller things fit that. So all my centimeters cancel out. The only thing I have left are meters. So meters are here, and what do we got here? 285 times 2.54 divided by 100. So I get 7.239 meters. Am I good? I'm not. What do I need to do? Sig figs. So my sig figs for this are going to be what? 7. Why does that seep happening? 7.24 meters, because I've only got 3 sig figs over here, so I can only report 3 sig figs. Rounds up because the number after that 2.3 is a 9, so I take that up to 2.4. Okay, let's do this 24.5 feet per second, turn that into miles per hour. So 24.5 feet per second. Doesn't matter which one I'm going to do, so I'll do seconds up here and 1 minute here. So 60 of those things, and then my seconds cancel out. And then I need 60 minutes and 1 hour down here, and my minutes cancel out. So I got the hour unit that I was looking for, and now I need to convert my feet into miles, and it's 5,280 feet is equal to 1 mile. So now my feet unit is gone. So then the only units that I have left are that mile and that hour, and so my answer is going to be in its correct units. So mile, an hour, and I got 24.5 times 60 by 5,280. And I got 16.7, 16.70. So my answer is going to be 16.7 since I have 3 sig figs there. Are we good with that one?
I try to cheat off, use your notes backwards. So it would be a lot easier to set it up like you had originally, but then you're going from miles an hour, or from feet per second to miles an hour. I was like, wow, thanks for making me.
Actually do something?
Yeah, actually do something.
Sorry about that. So by using the railroad track, the way this works is I don't have to know any equations. So I don't have to look up what the density equation is. What am I trying to solve here? What am I trying to get in this next question? I'm trying to find the volume. Okay, so what I need you to know is what is a unit of volume? So look in here with the information that I've got and find a unit that's got volume in it. Do we have one? There's only one. There's only this guy right here. That's got a milliliter unit in it. Okay, so the way I'm going to do this is, since that's the answer, the unit that I want, that's the unit that I want with my answer, I'm going to write milliliters. And, oop, I screwed up. There should be a 0 right there. 0.92 grams. Is that okay for me to write it upside down like that? I mean, 1 foot and 12 inches, and 12 inches and 1 foot. It doesn't matter which goes where. This density of whatever this piece of wood is for every milliliter, it's 0.92 grams. So it doesn't matter which one of those two things I put on top. That thing right there is still equal to itself. It's still equal to 1. It is a definition for that substance. So I put it upside down because what I'm trying to do is when I'm finished with this answer, the only unit that I want left is milliliters. And when you do the pro-calc exam, nursing or whatever other field, this is how you do it. There are no equations to determine how many milliliters per kilogram to give a baby for their medication, even though you've got all these different units in there. No formula. All I care about is when I'm done, I have the unit I'm looking for. And since this was asking for volume, the only unit I had available to me that had volume in it was milliliters. So I cancel everything else out to give myself milliliters. So when I put this milliliter unit into the railroad track, it came with a grams unit. That's fine. But now, before I'm finished, I need to get rid of the grams unit. So do I have anything in this given problem that can help me cancel out that grams unit? So where am I going to put it? I'm going to put 355 grams right there. Grams and grams cancel out. Now the only unit that I have left is this milliliter unit. And so as long as I don't type stuff into my calculator incorrectly, I will get 385.87. How many sig figs do I get? 2. That 0 in front doesn't count, the one that I just wrote there. So I've only got that 0.92. So then my answer is going to be what? 390 milliliters. We good with that? 385, there's a 5 there, rounds it up to 390. What am I not allowed to do with this answer here? What should I definitely not do? I should not put a decimal place after that 0, because if I did, that meant I knew it to the ones place, and I don't. I only know it to the tens place. Okay, I want to convert 100 degrees Fahrenheit into Celsius and Kelvin. So the last thing that we talked about in class on Wednesday were some numbers, 4 different numbers you should know in Celsius. What are they?
0.
0 is what?
Freezing.
Freezing of water. What else? 100 is boiling of water. What else? 37 is body temp. 17, 18, 19-ish, somewhere around there is like room temp. That's fine. So my answer here, or my question here is I want to convert my 100 degrees Fahrenheit into Celsius and then into Kelvin. What kind of Celsius number should you be looking for? A little bit more than 37. So if you get a number like 400, then something's wrong. Okay, so what am I doing with this? Well, if this was an exam and you had a question like this, the last page of the exam will have all of the equations that you could possibly need, so you can use this. Is it minus 32 first? Is it? 100 minus 32, and then 5/9. I know it has to be 5/9 because what happens to the Fahrenheit number when I turn it into Celsius? What happens to the size of the number? It gets smaller. So I know I'm going to subtract off 32 and I'm going to multiply it by the fraction 5/9 instead of multiply it by 9/5, which would make it bigger. I just sometimes can't remember which I do first, either the 5/9 or the 32. But it's really simple because once I'm finished with this, if this number is not somewhere near 37, then I know I did it backwards. So 100 minus 32 equals times 5 divided by 9 equals, great. I got 37.7 repeating degrees Celsius. And then I need to go into Kelvin. So to go Kelvin, then I'm going to add 273.15 K, or whatever, to get that. So let me add that, plus 273.15 equals. So this will give me 310.928 K. All right, so what should my answers be? 37.78 degrees Celsius. And then this one will be 310.9. Okay. 4 sig figs here, right? Where did that 8 come from?
It's because you rounded it.
It's repeating. If you would have looked at your calculator, it would have said 37.7777777. So it was a 3777. So I just rounded that up to 8. What's wrong? 273.15. Yeah. That's just the
Looks like a 1.
that's just the conversion to go from Celsius into Kelvin.
Is that 0.15 new? Yeah.
Yeah,
I don't have
that either. Okay.
Did I just give you 273?
Yeah.
Okay. Sorry. It's like 0.15, but it's not like super important.
Should we use the 0.15 from now on?
Whatever I give you on the test. If you gave me either one, I would have been totally correct. That's fine. All right, so 290K. So I want to convert that into Kelvin. So I'm going to need, or into Celsius. I need to subtract off 200. I'll just 273. Go with that. All right. So 17K, or 17 degrees Celsius. Okay. Degrees Celsius. And so then this one, I'm going to multiply it by 9/5, and then I'm going to add 32 to it. And then that'll give me a Fahrenheit. So what would I expect out of this? Like 70, maybe high 60s or low 70s, somewhere around there. Because 17, remember, Celsius was something around room temperature. So let's see, I've got 17
times 9 divided by 5 plus 32 equals. All right, I got 62.6, so my answer should be 63 degrees Fahrenheit. So that answer, and then that one for the last one, and then that one for the last one. Any questions about those two? No, not at all.
The disadvantage of having a projector sometimes gets a little bored.
Are you sure the
Well, I mean,
plasma TVs will be huge?
yeah.
It'll just be like screen, it'll be fabric TV.
No, we won't get fabric TVs. So we won't get good DPIs for video games.
We'll get fabric TVs that have higher DPI than anything we've had so far.
Will we though?
Oh yeah. Yeah. So
So, he had a really good question, but I don't know the answer. So 290 has two significant figures.
why would it have anything else?
We were just, he was just,
If it was 291, would it be 3?
It would be. But since it's a zero,
Just a placeholder.
the 0 is the one that you don't know. But how would it be three significant figures at 290?
If there was a decimal point at the end.
If there was a decimal place after the 0. So having that decimal place off is telling you that the thermometer that person used, tell me about something about that thermometer.
only does.
So it would read 0 degrees, 10 degrees, 20 degrees, 30 degrees. It would never read 25 degrees. It just doesn't have a mark for 25. But it'll read 290, 300, 310, but it can't give you any numbers in between. Okay, so brief non-scientific definition for density. Okay, how much stuff you can cram into something? Something else?
Put a certain amount of something, you
Not
can
highly.
stuff into a certain amount of something else.
That's what you wrote down? Something a little faster to say? Easier to think about?
How much mass can fit in a certain amount of volume.
That doesn't sound very scientific or non-scientific. What did you say?
I said weight related to sex.
Anything else? No, definitely not hardness. Definitely not.
Compactness?
Great. How compact is that substance? How tightly packed is that substance? So if this is a compact substance, it's a dense substance. And that has nothing to do with how hard it is, because again, lead is compact, but it's not hard. Gold is very compact, but it's not hard. So it's just how tightly packed that stuff is. So how compact the substance is. How compact is styrofoam? Not very, right? Water? Pretty tightly packed. I don't know. How about helium? Not tightly packed. Okay.
We have an opposite descriptor for like dense. Because I was thinking about I think yesterday. If you have something that's dense, what's the inverse of that word? So like if you have a binder that's light, well, I mean, if it's small, it still wouldn't be light, right? Like if this
Small
was
is
super-
volume.
Well, yeah, but like for density, if this is very like not dense, is that just what you call it, or is there another word? So I was trying to describe it to somebody else.
What we call
He said buoyant, but not necessarily, because no, I don't think there's an opposite to density. Just not dense.
Science is not going far enough.
All right, so what's the density of a piece of wood with a mass of 240 and a volume of? Okay, so I'm looking for a density in this question. What are the units for density? Mass divided by volume. So what I need is a mass unit divided by a volume unit in my answer. And I've got a mass unit and I've got a volume unit. So I'm just going to take the 240 grams as my mass unit and my 268 centimeters cubed as my volume unit. and I'm not going to cancel anything out because I don't want to. And so I've got 240 divided by 268, and then I've got 0.8955. How many sig figs? Try again. There's no decimal place after the 240, right?
Yeah.
So only 2 sig figs. So what's my answer? It's going to round up.
0.9.
There you go.
Thank you.
0.90 grams per centimeter cubed. So it's 2 sig figs. That first 0 is just a placeholder letting people know that there's a decimal place there. But I need 2 sig figs. So how come that 0 after the 9 is significant?
It's a significant figure.
Because I wrote it.
Why is that significant?
Because who would write a 0 after a decimal number if there wasn't a reason behind it? Does that make sense?
Yes.
All right, so
Because if it was just 0.9, it, like if you were to write it out, it wouldn't make sense. Because I mean, if you got 0.90, then you would not just write.
all right, how about this? I measured something at 1.5 feet. All right. If I did that, would I ever just randomly throw some zeros after it? No. I mean, if I measured it and it was 1.5, would I just, does that make any sense? Would I just do that? If I did that, that means something important about the number. And in this case, what would this number's importance be?
It could be another thing. It could be a 9.
It's not 1.49.
No. It could be anything.
No, it can't.
What do you mean it can't?
It's not. That 0 right there is a significant figure but it can't. It's a 0. It's not a 0 up to a 9. It's 0 exactly as 0. This 0 right here was written because I used a measuring stick that measured this down to the 10th place. Does that make sense? My measuring stick was accurate enough to tell me down to the 10th spot, and it just happened to hit 1.50 right on the button. Not 1.51, because maybe it was going to hit 1.49 or 1.51, but this one hit 1.50, and I know exactly it's 1.50. But what if I'm measuring here? This top one. Tell me about the thing that I used to do the measurement.
It could that have been like 1.49 and then rounded up?
No, because if that was the case, I would have written 50. Tell me again, what did I say about this device that I used to measure this?
Accurate enough that it could go.
It measured it accurate enough to go to the 10th place. Tell me about this ruler here.
It was accurate.
It only measured to the ones place, right? We okay with that? And this one, this measuring stick here,
Super accurate.
really ridiculous. I probably needed a magnifying glass to read it, right? Or a microscope even. Probably a microscope, because this is 10,000th of a foot. So I need something powerful enough to read. And that's how they got that 2.54 centimeters equals an inch. They made something that was an inch long and put it next to the ruler that was accurate to many, many decimal places, and it nailed right there on 2.54. I mean, that was it. It wasn't in the front and in the back. It was right on it. That's why that one says exact. Okay.